Hello and thanks for using TickBoom. In this question I'm tackling part 4, which is the last part of this 4-part question. And this video follows on from 3 prior videos where I worked through part 1, 2 and 3 in turn. So if you haven't watched those videos, I recommend that you do, because this part 4 will build upon what we've been able to prove in those earlier parts. The first thing worth noting for this final part is that it's only worth 2 marks compared to all the other parts which were worth 3. So I think that gives you a little hint that there should be some nice, simple, elegant way to do this final part. It shouldn't require as much effort as what we took in the earlier bits of this question. So what the question is asking is that we want to prove that 2 to the power of n times n factorial squared, all of that squared, is less than or equal to 2n plus 1 factorial. And you may notice this inequality looks like a rearrangement of the result that we proved in part 2. So I think right away that gives us the hint that we can use what we've already demonstrated to help show this inequality. And I think that's worth noting because it probably is also possible to try and prove this inequality using induction. I haven't actually tried myself, but I think you probably could get there, possibly. But I don't think that's what the question writer intended here. I think you can see quite clearly they're building us up to this final part from everything that we proved before. So I think it's only natural that you try and make use of that information to tackle this. So I think I'll just write what we're trying to prove just to start. So we're trying to prove that 2 to the n times n factorial squared is less than or equal to 2n plus 1 factorial. And I think it's worth just reminding ourselves what we showed in the earlier parts. So from part 1, we showed that in is equal to 2n on 2n plus 1 in minus 1. And in part 2, we showed that in was equal to 2 to the power of 2n times n factorial squared on 2n plus 1 factorial. And also, as part of our working out in part 2, we also showed that I0 was equal to 1 by evaluating that integral. And I think that will come in handy too. Because if I kind of build up from here and make use of the recursive result that we showed in part 1, if I can say I0 is equal to 1, then I1 would be equal to 2 times 1 on 2 times 1 plus 1 times I0, which would be equal to 2 on 3 times 1, which is just 2 on 3, and that's less than 1. Now if I then look at I2, that would be equal to 2 times 2 on 2 times 2 plus 1 times I1, which would be 4 on 5 times 2 on 3. So we've got 2 fractions both less than 1, so when you multiply them you'll also get something less than 1. And I'll do this one more time just to make the point. I3 would be equal to 2 times 3 on 2 times 3 plus 1 times I2, which would be 6 on 7 times I2, which is 4 on 5 times 2 on 3. And again, this will be less than 1. And that pattern will continue for any in, because every time I'm evaluating in, I'm going to get a fraction less than 1 multiplied by the prior result, which will also be a fraction less than 1. So in will be less than or equal to 1, and the equality comes at I0. So from there, I think we can then get to what we're trying to prove, because if in is less than or equal to 1, then that means this result in part 2, 2 to the power of 2n times n factorial squared on 2n plus 1 factorial is less than or equal to 1. And I'll just bring this denominator up. So we'll get 2 to the 2n n factorial squared is less than or equal to 2n plus 1 factorial. And this is really just the same thing, we've just brought the 2 out, so it's really 2 to the power of n times n factorial all squared less than or equal to 2n plus 1 factorial. And that's what we were required to prove. So as I noted at the beginning, because we've worked through all the prior parts of this question, this final proof becomes quite simple. Whether you could prove it by induction, I'm not sure, and whether that would be this simple, I doubt it. So you can kind of see how the question writer has guided us through. And so in the end, this last question of the exam, it's quite a nicely written question. It's quite a good one to work through, because you get to see how you can prove certain results by breaking them up into little steps. And I think looking back at the 4 videos that I've just created, the real kind of challenge to this question, the thing that made it worthy of a final question of the 4-unit exam, was part 3, where you really did have to have a level of creativity to get to that result. But that said, the beauty of this question is that even if you can't work out all of it, you can almost you get to set the slate clean at each part. You get to rely on what you've shown even if you couldn't show it. So you always have a chance of picking up some marks, because for example, this part here you could have had a fair crack at. Even if you didn't get the result in part 2, you know what it was, they tell you. So hopefully you could have picked up the final 2 marks in this question. So hopefully that all makes sense. And that for all of the parts of this exam question that you've been able to follow along and hopefully you've learned something through all this. And tick boom.